The directions say to find the derivative of the function using the definition of the derivative. State the domain of the function and the domain of the derivative. Let's take a look at example 1. Suppose we are given f of x equals 3x minus 8. F of x plus h is equal to 3 times the quantity x plus h minus 8. If I distribute the 3 inside to each term within the parentheses, I get 3x plus 3h minus 8. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h. And so this is the limit as h goes to 0 of. Now in the numerator, I get 3x plus 3h minus 8. And then this is minus the quantity 3x minus 8. And we're going to take that whole thing and divide by h. And so this is the limit as h goes to 0 of. Now in the denominator I have h. In the numerator I have 3x plus 3h minus 8. And I'm going to distribute the negative inside to each term within the second parenthesis. And so I get minus 3x plus 8. So I'm going to cancel the 3x here, and the negative 3x, those two terms go away. And then negative 8 and positive 8 also go away because those respective terms add to 0. And what we're left with is the limit as h goes to 0 of 3h over h. And this is the limit as h goes to 0 of 3, which is equal to 3. And so that tells me f prime of x is equal to 3. The domain of f of x is all real numbers. The domain of f prime of x is also all real numbers. Example 2. Suppose we're given f of x is equal to x squared plus 5x. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And I want to get a handle on f of x plus h. F of x plus h is equal to x plus h raised to the second plus 5 times the quantity x plus h. So this is x squared plus 2xh plus h squared plus 5x plus 5h right here. And so f prime of x is the limit as h goes to 0 of x squared plus 2xh plus h squared plus 5x plus 5h minus the quantity x squared plus 5x, all divided by h. And so this is the limit as h goes to 0 of x squared plus 2xh plus h squared plus 5x plus 5h minus x squared minus 5x all divided by h. And you notice over here I distributed the negative to each term within those second set of parentheses. And that's what I get on this page. And so what I get now is the limit as h goes to 0 of 2xh plus h squared plus 5h all divided by h. Notice how every term in the numerator contains a factor of h. So if there is a term with no factor of h, that means we made a mistake somewhere. Okay. Now, this is the limit as h goes to 0 of h times the quantity, 2x plus h plus 5, all divided by h. Notice how the h's cancel. And so we get the limit as h goes to 0 of 2x plus h plus 5. And I'm going to substitute in 0 for h. And when I do, I get 2x plus 5. So f prime of x is 2x plus 5 by definition. And the domain of f of x is all real numbers. The domain of f prime of x is also all real numbers. And that right there is example 2. Let's take a look at example 3. Suppose f of x is equal to the square root of 9 minus x. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And so this is the limit as h goes to 0 of the square root of 9 minus the quantity x plus h minus the square root of 9 minus x all divided by h right here. And I'm going to distribute the negative inside to these parentheses here. And when I do, I get the limit as h goes to 0 of square root of 9 minus x minus h minus the square root of 9 minus x all divided by h. And what we want to do is rationalize the numerator. And to do that, I'm going to multiply the numerator and denominator by the conjugate of the numerator. In other words, I'm going to multiply the numerator and denominator by the square root of 9 minus x minus h plus the square root of 9 minus x, all divided by the square root of 9 minus x minus h plus the square root of 9 minus x. So this is the limit as h goes to 0 of. Now, I get, in the numerator, I get 9 minus x minus h minus the quantity 9 minus x, all divided by h times the quantity, and it's h times the quantity, the square root of 9 minus x minus h, plus the square root of 9 minus x. So I'm going to distribute the negative inside to those, or to each term in the second set of parentheses. And when I do, I get the limit as h goes to 0 of 9 minus x minus h minus 9 plus x, all divided by h times the quantity, square root of 9 minus x minus h plus the square root of 9 minus x. So over here, this is the limit as h goes to 0 of negative h over h times the quantity, square root of 9 minus x minus h, plus the square root of 9 minus x. Remember, h is not 0, so I'm allowed to cancel those h's. And when I do, I get the limit as h goes to 0 of negative 1 over the square root of 9 minus x minus h plus the square root of 9 minus x. So the key to this problem is you need to rationalize the numerator. That's the big idea for a problem like this. And so in the end, I get negative 1 over 2 times the square root of 9 minus x. And so what that tells me is f prime of x is negative 1 over 2 times the square root of 9 minus x. The domain of f of x is the set of all x for which x is less than or equal to 9. Another way to write this is you can write this as negative infinity to 9, where 9 is inclusive. And you represent that by a closed bracket. The domain of f prime of x is the set of all x where x is less than 9. And the interval is negative infinity to 9, and it's not including 9. And it's not including 9 because I don't want division by 0. If I replace x with 9 in f prime of x, I have division by 0. That's bad. And so this is the domain for f and f prime. Right here and here. Let's take a look at example 4. Suppose we are given f of x is equal to x to the 4th. F prime of x is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. I need to get a handle on f of x plus h. f of x plus h is x plus h to the fourth. I claim if I expand all that out, I get x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth. So f of x plus h is the hard part. Now, when I plug this in, I get f prime of x is the limit as h goes to 0 of x to the fourth plus 4x cubed h plus 6x squared h squared plus 4x h cubed plus h to the fourth minus x to the fourth, all divided by h. Notice how the x to the fourth term cancels out this negative x to the fourth term. And notice that each term in the numerator has a factor of h there. And you want that. And so this is the limit as h goes to 0 of 4x cubed h plus 6x squared h squared plus 4xh cubed plus h to the fourth over h. I'm going to factor out an h from the numerator. And when I do, I get the limit as h goes to 0 of h times the quantity, 4x cubed plus 6x squared h plus 4xh squared plus h cubed, all divided by h. Now remember, h is not 0, you guys. So I can cancel the h's here. And when I do, I get the limit as h goes to 0 of 4x cubed plus 6x squared h plus 4xh squared plus h cubed. And by direct substitution, this is equal to 4x cubed. So what that tells me is that f prime of x is equal to 4x cubed. The domain of f of x is all real numbers. The domain of f prime of x is equal to all real numbers. Now, one thing I want to show you, recall, a squared minus b squared is equal to a plus b times a minus b, right? So if I have x to the fourth minus, let's say, y to the fourth, this is x squared raised to the second minus y squared raised to the second. And this is x squared plus y squared times x squared minus y squared. And I could take that a step further, and I could write this as x squared plus y squared times x plus y times x minus y. So you could do something very similar to this problem. So, in other words, when I have x plus h to the fourth minus x to the fourth, if it's too much to expand x plus h to the fourth, we can factor this difference. We can factor this into x plus h squared plus x squared times the quantity x plus h squared minus x squared, right? And I could take this one last step. So I can take this as x plus h to the second plus x squared times x plus h plus x times x plus h minus x. So x plus h is being treated like y. And so this second bracket here ended up being a difference of squares. And notice on over here, right? Notice how the x's cancel, and I'm left with h. So it's just a different way to look at the same problem. And with that, let's take a look at example 5. Suppose I'm given f of x is equal to 1 minus 2x divided by 3 plus x. So this is a rational function, and with a difficult problem like that, what we want to do is get a handle on f of x plus h minus f of x first. So f prime of x right here is the limit as h goes to 0 of f of x plus h minus f of x all divided by h. And I'm going to look at f of x plus h minus f of x. So this is 1 minus 2 times the quantity x plus h divided by 3 plus x plus h minus 1 minus 2x over 3 plus x, just by substitution. So this is 1 minus 2x minus 2h divided by 3 plus x plus h minus 1 minus 2x divided by 3 plus x. My common denominator is 3 plus x plus h times 3 plus x. Notice that's right here. In the numerator, we get 3 plus x times 1 minus 2x minus 2h minus 1 minus 2x times 3 plus x plus h. And notice I multiply everything out, nothing fancy. So this is equal to 3 minus 6x minus 6h plus x minus 2x squared minus 2xh minus the quantity 3 plus x plus h minus 6x minus 2x squared minus 2xh, all divided by 3 plus x plus h times 3 plus x. So I'm doing a lot of legwork in the beginning here. And so notice here, I end up with negative 7h, all divided by 3 plus x plus h times 3 plus x. So now, let's remember, that is what f of x plus h minus f of x equals. It's negative 7h divided by 3 plus x plus h times 3 plus x, like so. So f prime of x is the limit as h goes to 0 of negative 7h over 3 plus x plus h times 3 plus x, all divided by h. And remember, think of this h as h over 1. And so remember, when you divide by a fraction, you multiply by the reciprocal. And so this is the limit as h goes to 0 of negative 7h over 3 plus x plus h times 3 plus x times 1 over h. But the h's cancel, and we are left with negative 7 over 3 plus x to the second. And so f prime of x is negative 7 over 3 plus x raised to the second power. The domain of f of x is the interval negative infinity to negative 3 union negative 3 to infinity. The domain of f prime of x is negative infinity to negative 3 union negative 3 to infinity. So essentially all real numbers except x equal negative 3. And that'll do it for this video. Okay, thank you.